Okay, let's start looking through the second question that was here. Now, this question has a suggested maximum time of 20 minutes. It's a much longer question with more parts to it, but in a way, it's a lot more accessible than the first question that we looked at. It's a lot more like what we were doing in class and doing for homework. So they've shown us a coordinate diagram of a town where Cleona lives, and each small square in the grid has a length of 1 centimetre. Write down the coordinates of the shop, home and school. So this is what I'd call an everybody question. Everybody should be able to answer part A if they've done any kind of study at all. So the shop is at -3, 1. Remember the x values first and then the y values. Home is at 4, 2. And school is at 4, 5. So there we go, the coordinates filled in. The library is at the midpoint between home and the shop. Do you think we'd get full marks if we did this by measuring and found out the coordinates of the library by the halfway point here? Well, depends on how accurate it is. Looks like it's probably around here. So I'd say 1, 1.5 for the library. Would we get full marks for that? Well, they just said write down, so you might, but it's better to use the formula because we can be sure that we're going to be accurate then. So my midpoint formula is the average of the x values and the average of the y values. That's how I remember it. It's in our log tables, of course. What are my x1, y1, x2, y2? Well, the shop is -3, 1 and home is 4, 2. So I label those as x and y. This is my first point and this is my second point. Then when I fill into the formula, and you do this a lot more quickly than what I'm doing here, the library should be at x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this gives me, did I fill these in right? -3, 1, 4, 2. Oh, okay, that's fine. So this gives me 1 over 2, or a half. And this gives me 3 over 2, or 1.5. So my estimate here, when I drew this in, because I didn't measure it, the library actually should be more like here. Okay, it's at the halfway point. So we definitely wouldn't get full marks for just writing it down based on our estimate if we didn't measure it correctly. So there's the coordinates of the library, 0.5, 1.5, or you can do it as a half, 3 over 2 as well if you'd prefer. Now, work out the distance from the home to the shop on the diagram. And again, we're going to write down the coordinates of the home, 4, 2, the shop, -3, 1. It doesn't matter which way around we write them. My distance formula is the difference between the x values squared and the difference between the y values squared. Oh, my pen has decided to stop working. Y values squared there, where this is my x1, y1, x2, y2. So we fill into the formula and we get that the distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. You can put that into your calculator in one go if you want. I'm going to do it in a few different steps though. So this is going to be -7 squared, which is 49. This is going to be a -1 squared, which is a +1. And that gives us the square root of 50. They asked us to write it correct to 2 decimal places. So we do have to use our calculator then to calculate the square root of 50, which is 7.07. 7.07 centimeters. Now, of course, her house isn't centimeters away, but on the map it is. That's where the scale is coming in. So the distance on the diagram from the shop to the school is roughly 8.1 centimetres. The diagram is at a scale of 1 to 2500. That means that I've got to multiply this by 2500 to find the actual distance. So for every 1 centimetre on the map, it's 2500 centimetres in real life. So 8.1 multiplied by 2500, 8.1 by 2500, and that is, they want our answers in meters though, 20,250 centimetres, and to convert that to meters, we divide by 100. So that is 202.5 meters from the shop to the school. Cliona walks from the shop to the school. Explain why the distance she walks is probably more than the actual distance. Okay, so let's look shop to school. We could use a ruler here. We're saying that's around 8.1 centimetres. And in real life, that's about, what did we say, 202 metres. Why would she walk further than that? You have to think about it. It's a real life problem now. This isn't something that we necessarily use in maths or learned in maths, but it's common sense. Do we walk straight lines like this when we're walking from one place to another in the real world? Of course we don't, because streets curve and you've got to turn corners and you've got to avoid obstacles. So the explanation here is that she won't be able to walk in a direct straight line probably, we don't know for sure, due to obstacles and street shapes. Okay, so not really a maths question there, but they're testing, do you understand how the real world works and how maps work? Now, the next part of the question here, our coordinate diagram has the line L drawn from the shop to the school. I'm going to fill in my coordinates here again, minus 3, 1, and the school is 4, 5. And they want us to work out the slope of the line L. So again, we have a formula for that. The slope is the difference between the y values, the rise, divided by the difference between the x values, which is the run. I'm just going to label them here, x1, y1, x2, y2. Again, it doesn't matter which order you do that in, you'll get the same answer. So 5 minus 1 divided by 4 minus a minus 3 is plus 3, giving me 4 over 7. Did I answer the question? Slope of the line, yes, and I gave my answer as a fraction. And part G, find the equation of the line L. And they want us to give it in the format that we've been doing all along. So we're going to use y minus y1 equals m by x minus x1, where I might as well just use the x1, y1 that I have here, minus 3, 1, doesn't matter which of the 2 points we use actually, and the slope is the one that I just calculated. So I've got y minus 1 equals 4/7 by x minus a minus 3, x plus 3, and then the 7, or shortcut, multiplies the y side, the 4 multiplies the x side. We've got 7 by y minus 1 equals 4 by x plus 3. Multiply out our brackets. 7y minus 7 equals 4x plus 12. Bring everything to one side. Minus 4x plus 7y minus 7 minus 12 equal to 0. Minus 4x plus 7y minus 19 equal to 0. And then change the signs. So this will become plus, this will become minus, and this will become plus. My answer is 4x minus 7y plus 19 equal to 0. There's the equation of the line. Okay, so again, I would hope that almost everybody would be able to answer these questions here. Now, the last question is something we can't do yet because we haven't done trigonometry. The slope and the size of the angle there. So we'll just put a star next to that. Something for you to revisit after we've done trigonometry. Revisit after trigonometry. I'm going to tell you that we're going to use something called sine. The sine of the angle is opposite over hypotenuse. So don't worry about it for the moment because we haven't learned about that yet. So that's everything that we needed to do for that question. So something to think about. Which of those two questions did you actually find easier to do? And what can you do to help yourself approach questions when you find what you're being asked confusing? We might have a bit of a talk about that next week. Okay, thanks everyone.